Number 78. Using Lewis structures, write balanced equations for each of the following reactions, and then we have this reaction right here. So we have to see what happens when NH4 plus comes together with C2H5O minus, right? What are the products? Well, we got to write Lewis structures. So that shouldn't be a new thing here. There's a chapter specifically for drawing Lewis structures that we've done on the channel. I believe it's like chapter 7 in this textbook. So if you do need a full recap on how to draw Lewis structures, I go, in depth back there, step by step how to do it. But this is going to kind of be like the quickened version. I did write the valence electrons down here, just as a guide here, which I'm going to use. But other than that, let's get going. So we have to draw the Lewis structure for NH4 plus. So remember, hydrogen can't be in the middle. So nitrogen has to be in the middle, surrounded by 4 hydrogens. So 1, 2, 3, and 4. Each hydrogen has 1 valence electron, so I'm just going to put 1 dot around each hydrogen. And the nitrogen has 5 valence electrons, so 1, 2, 3, 4, 5. But this plus means that along the way, somebody lost 1 electron. So I have to pull 1 electron from here. And it seems like all of these are nicely lined up except for this up here, right? This already has a pair. So I'm just going to get rid of 1 of the nitrogen's electrons. And now I'm going to single bond them up. So let's see, single bond, single bond, single bond, and single bond. And specifically, what element has that positive charge? It's the one that lost the electron. It was nitrogen that we literally erased. So I could put the plus next to the nitrogen. That would be nitrogen's formal charge. Now, I'm just going to draw the next compound. So this plus C2H5O. Now this one might be a little bit tricky. Remember, the hydrogens are not in the central, right? They're never in the center. So it seems like I have 2 carbons strung along with an oxygen. So I'm going to say C, and O. Now, it doesn't matter whether I put OCC. I don't care. So we'll do it that way. We'll say C, O. And now I have to put 5 hydrogens around the carbons, right? So I'm going to put, let's see, 1 hydrogen here. I need to space this out a little bit. I'm going to put 1 hydrogen here. I'm going to put 1 hydrogen here. 1 up top here, and 1 down below here. So that's my representation of this. Each hydrogen has 1 lone electron, so 1 goes for each hydrogen. Each carbon has 4, so 1, 2, 3, and 4. 1, 2, 3, and 4. And each oxygen has 6, so 1, 2, 3, 4, 5, 4, 5, 6. And this compound has a negative charge, which means that this one gained 1 electron. Generally, you'll always gain it to the more electronegative element, which is the oxygen. So I'm just going to add that guy right here. Single bond them up and see if we have the octet. And when we do that, seems like everybody actually is happy. Now, who actually gained the negative, right? Who gained the 1 electron? It was the oxygen. I'm just going to put a negative next to the oxygen specifically. Okay, well now what's going to happen? Well, we have to identify what type of reaction is going on here. Remember, NH4 plus, right? Whenever we see pluses and minuses, we think acids and bases. NH4 plus, whether you think of it as a Bronsted-Lowry acid or a Lewis acid, it kind of is the same as what's going to happen. So I'm just going to say that this is an acid overall, which means that this has to be the base. And bases always kickstart the reaction because electrons always kickstart the reaction. So in terms of a Lewis base, the base will always have a lone pair that will want to grab a hydrogen from the acid. Remember, the acid always loses 1 hydrogen because it goes to the base. Now, when it loses the hydrogen, these electrons don't come with it. Only the element H comes along for the ride. These electrons stay put, and these electrons will now go back to the nitrogen. So let's do that, right? So what's going to happen is the lone pair on the base, specifically it's going to be the oxygen, is the one that's going to grab the hydrogen. And I'm picking the bottom one here because it's the easiest for me to grab. Then what happens is these electrons break as a bond and they go back to the nitrogen. So let's just see what that looks like. So if I actually just copy this, right? We have this. And it turns out that this hydrogen is now gone. Bye-bye. And these electrons in the bond, they're not a bond anymore. They're now a lone pair. They group together and now they're resting right on the nitrogen. And if we did the formal charges, nitrogen is now back to neutral. And that kind of makes sense, right? This is NH3, and NH3 is always a neutral compound. Now let's just find out what's going to happen to the other one. Let's see, can I squeeze this anymore? This might have to be redrawn. Maybe I can... Oh boy. Let's see. Really trying here to squeeze it all in one line. I might have to just zoom this. You know what I'm going to do? Ooh. I'm just going to resize this. And I think if I resize it, I think I can fit both of them. Just barely, but we got the point. Okay. So it's this plus this. Okay. So now we have to gain the hydrogen from here. Remember, that's this hydrogen. So over here, we have an H. And how do we form that bond? It's the oxygen's 2 electrons that say, hey, that's okay that you just came over with no electrons. I got you, right? I have the 2 electrons. I can use those to make the bond. So they won't be a lone pair anymore. They'll be a bond. So now it's just going to be a bond to the H. And when that happens, if we redo the formal charges, this does not have a negative charge anymore. It's now back to neutral. And that's what the compound is. So it basically is this, but we just added the hydrogen. C, you could say C2H5, H6O, or you could say C2H5OH. There's a lot of different ways that you can say the compound. But this would be your answer. So the whole balanced equation would be NH4 plus C2H5O minus yields NH3 plus C2H5OH. And that is the Lewis structures to show it. Okay, I really hope this helped you out. Let me know in the comments. Subscribe to the channel, and I hope to be teaching you future lessons in the future. Anyway, yeah, it's pretty late, so I'm going to go to bed. Okay, bye-bye.